Hello, hello. Good evening, Sir Aliyah. I am Aliyah Regacho, one of your students under the Intelligent Systems section F1 in BSCS-3. What I will be doing for tonight is I will be demonstrating the AliacSearchAlgo application. Basically, we were tasked to correct the code for the search algorithms. And after reviewing the codes shown in the screen, I noticed that the main issue was in the way the fringe was implemented. So let's go first to the fringe class. So this fringe class is actually meant for depth first search. And in here, it was using a queue instead of a stack. Meanwhile, for the fringe 2 class, which is meant for the breadth first search, this is meant for queue, but in here it was using a stack. So to fix this, I'm just going to comment out the wrong parts of the code and include this already commented out lines. So we're just going to swap the implementation. So in here, instead of DQ, we will use return as the top. Then I think this is it for the fringe using the stack. And then for the fringe too, it is supposed to be using Q. So we're just also going to swap this. So it's MQ instead of push and this one instead of pop. So this is the corrected implementation for fringe 2. It now uses the methods for Q. Thank you. And for the fringe, we're also using the methods for stack. So stack and then push and then pop. So these are the only corrections that we are going to implement for this program. And we don't need any other revisions for the other parts of the code. So now I will be demonstrating by providing an example input. So let's start. Let's run the program. So I actually already created a node. So we're just going to load it. So I'll be using this file named sample. So here, as we can see, this 2, 4, 6, 8, 10. So these are 10 nodes. And what I'll be doing now is that I'm going to set the starting node, which is this one, and the goal node, which is this one. So this is the starting node and this is the goal node. And let's try to implement it using the BFS. Let's click the full search. So as we can see, it says found J. And if we click OK, this is the code. So this is the output for the corrected code for the breadth first search. So I'm just going to take a screenshot for documentation purposes, and we're going to compare this with the output of the uncorrected version. So now I'm going to reset this first, and then that's it. So that's the output for the corrected code. But what if, or what's gonna be the output for the uncorrected code? So we're just going to Control Z and let's go back from the start. And for the fringe as well, we're just going to reset it. Okay, so this is the original code. So for French, it uses the Q, and then for the French 2, it uses the stack. So now let's try to run and see what it shows. So I'm just going to load the node again, and then I'm going to set the starting node and the goal node, which is still the same. So now if we try to click or if we try to um, implement using BFS, it says it found J, but the path, we can see that it is kind of different. So I'm going to show you the uncorrected. Okay, so this is the uncorrected version, while on my right side, this is the corrected version of the BFS. So here in the uncorrected version, what was supposed to be BFS behaved more like adapt first search. So that's why the path looks like it jumped directly from here, the starting node, towards the goal node instead of going through each layer of the path. But here on the other side, which is the corrected version, we can see that the BFS now works properly. We can see that it works properly because it explores level by level or layer by layer, checking that all nodes at one depth before moving to the next. That's why the path looks a bit longer visually, but this is correct because BFS guarantees the shortest path in terms of the number of steps or edges. So in summary of this short demonstration, the correction was all about using proper data structure for each search type. So with the right implementation, BFS explores by diving deeper first, while BFS explores by layers, ensuring that the shortest path in steps from the start to the goal. So thank you so much for listening, and that's it for my demonstration.